We're going to quickly talk about the experimental design and some of the parts that are important to it. So the first question to consider is the key components to an experimental design. So we'll be doing experiments throughout the year in physics. So how do you appropriately design an experiment to collect the information you want? And then secondly, how do you use graphs and tables to communicate these findings? And then the third part is the idea of a constant and a control. Those are different concepts, and the problem comes when different people use alternate terminology, but as long as you understand the idea behind what a control and what a constant is, that'll be an important part of this year. So let's just take a minute and look at a scenario for an experiment where you can, like a Marquette student wants to decide what type of material would be best to make a paper airplane. He and his group decide to make a traditional paper airplane out of printer paper, notebook paper, cardboard, and aluminum foil. Then they drop each airplane off the edge of the balcony and measure the distance traveled. So the independent variable is the aspect of the experiment that the experimenter wants to change. Aspect changed. By experimenter. And then the dependent variable is the component that is measured, so the outcome that's measured by the experiment. So I'd like you to consider our sample from before when we changed the different materials for the airplane and we measured the distance that it traveled. So when you're setting up a data table, if you remember from algebra class, we have set up and if we're trying to graph points, we do the x component in the left-hand column and then the y component in the right-hand column over here. We're going to follow that same sort of protocol when we are setting up experimental design tables, but instead we are going to set up the independent variable here, independent, here, and the dependent variable is going to go in the right column. And this is kind of important, especially since most of you are going to use computers when you are setting up your data tables. The units have to go in the heading. So the units will go here. So for example, in our experiment, if we were measuring if the distance traveled is the dependent and we're going to measure it in meters, we simply put meters in the heading. I don't want units and numbers mixed together in the data column. So be sure that you put the independent variable on the left column, right here, and the dependent variable on the right column. And if there are units, those should be included in the heading, not in the data column. So for our example, the thing we were changing was the material. So we have paper, regular paper, we have cardboard. One example was aluminum foil. And I think there was a fourth one. But anyway, the things we change should be added to the table, and they can be added to the table before you even do the experiment. And then once you finally make your measurements, let's pretend that we measured some values. So if we threw a paper airplane and we recorded that its distance traveled was 30 meters, the cardboard would have traveled maybe less, and then the aluminum foil, let's just hypothetically say that it traveled the least. So in this case, we have our independent variable with the values or measurements that are already known, and then the dependent variable has its values and measurements known there. So when we write a graph, the graph setup is supposed to be set in a way where, as you know, this is the x column down here would go on the x-axis, and the y column from your data table would go on the y-axis. So if we follow the pattern that we were just using, that means that the independent variable will go on the x-axis and the dependent variable will go on the y-axis. And your graphs must include units. So every time we do a graph for this class, units must be included. And it also must have a title. So an appropriate title would be whatever the y-axis is versus the x-axis. So from our example, we could have done distance versus material of the airplane. So the material goes down here, and then the distance and the units for distance would have been meters. And in this case, since this value down here is qualitative, we would probably use something like a bar graph. If you have a qualitative x-axis and a quantitative y-axis, you can use bar charts. If you have a quantitative number down here and a quantitative number up here, then we're going to use a line or like a scatter plot. So after we plot the points, then we will do the best we can to fit an appropriate curve to it. The last thing I want to talk about is the difference between constants and controls. So like I mentioned before, some people who they understand this concept, they just use different terminology for the same idea. I know, for example, that Mr. Vogt will use the term controlled variable for the word constant, and that's appropriate and acceptable, but I use the word control to mean a specific set in an experimental group. So let's consider this example. So if you are in charge of a drug trial, if you're trying to test a pharmaceutical that you'd like to administer to the general public, the first thing you need to do is to run a clinical trial. One way you do that is you have a control group. Actually, you'll have two control groups, and then you'll have your experimental group. So if you have a group for which you give, let's say there's 900 people, and you put 300 people in each group, 300 people and 300 people. So let's call this one group A, and we'll call this one group B, and we'll call this one group C. So if in group A, you have 300 people in group A, and you give them a placebo, and if you remember from biology, a placebo is a pill that is nothing. It's like a sugar pill. It should not produce the impact that you want it to. So this would be the negative control group. Okay, so for the group of people who are receiving this medication, nothing should happen. Now I'm going to jump to group C, which is targeting the drug, the one that you're trying to make. So if the drug you've produced is able to or attempts to lower blood pressure, that's the experimental drug. So we're going to give this group to, we're going to give group C the group of the experimental drug. So this is called your experimental group. And if, again, we said this drug is, the attempt is to lower blood pressure. Now I'm going to go back to group B, and group B is a group that you give an ACE inhibitor to. So this drug, it already exists, and we know for a fact that it over time is able to lower blood pressure. So we'll call this a control group. But one pharmaceutical company might say, the side effects of ACE inhibitors are not very desirable, and we think that our experimental drug can produce the same impact with fewer side effects. So in this case, you have two control groups and an experimental group. To every single group, you do the best you can to maintain the rest of the variables as constants. So you're going to try to do the best you can to put people of the same age in the same groups, and people who have the same lifestyles in each group, and anything else that you could consider that could impact your blood pressure over time, that would have to be considered and implemented as in the experiment. The last question I'd like to leave you with is if you know what the mama buffalo said to her son on his first day of school. That's all I have. Let me know if you have any questions.